we were writing equations of lines given information, right? So now, if I'm given a point that a line goes through and the slope of the line, which form do I want to put that into to start with? Think about the forms we have for lines. I want all earbuds, all that stuff gone too. If you got any earbuds in, take those out, phones away, please. So we got three forms for lines that we're used to. We got slope-intercept form, which is the standard we almost always go to, right? Y equals mx plus b. We've got standard form, which we use in some situations. That's not quite as much, but sometimes. And then we have this specialized one, point-slope form, remember that we talked about last. Point-slope form is really never the answer, it's the starting place to get the answer, right? Point-slope form is the one that we use, and it's named for what it requires, a point and a slope, right? So when we have a point and a slope, that fits into point-slope form. Remember, this is point-slope form, right? Y minus y1 equals m times the quantity x minus x1, where m, of course, is the slope, and x1, y1 references the coordinates of a point that we know that's on our line, right? And then this is just m, isn't it, right there? And we would plug that stuff in, and then to put it into slope-intercept form, we would just solve for y and simplify. Okay, now on this question, though, they're not asking us to do much at all. All they want us to do is plug the stuff into point-slope form and stop. You don't have to do anything else, right? This is where we ended up. And so we got our value of y1 was -7, so we got y minus -7 becomes a y plus 7. Our value for m was 5, and our value for x1 was also 5, right? And so that's where we would stop. Okay, if we were going to go one step further, what about one like this, where now they want us to write the equation in slope-intercept form? Well, where do we start them if we're given a point and a slope? Which form do we start with? Y minus y1 equals that same one we just had. What's that one called again? Point-slope form. There you go. Right. So we're starting with, because we have a point and a slope, that's where we start. So, and you got to know these. I added 2 more questions to the test that are just freebies for you. I mean, all they are is you've got to. I'm going to randomly pick 2 of the 4 formulas from this chapter, and you got to remember what they are right now. Which is that last assignment I gave you. Okay, so real quick, remind me again, everybody together, what is point slope?
y minus y1 equals m times x minus x1.
Good. And we'll just plug in our stuff then. So what do we get here? 18. What goes here?
8/3.
What goes here?
9.
Okay, so there it is in point slope form, but now they want us to write this in slope intercept form, right? So that's where we start. Well, what do we have to do to put it in the slope intercept form? We're going to distribute and simplify and all that stuff, right? So we'll distribute the 8/3, which gives us what? If I distribute the 8/3, what am I going to get? Good, so I get 8/3 x minus 9 over 1 times 8/3, right? When I distribute the 8/3 to that number. Okay, well, what can we do there? I can multiply straight across. When I'm multiplying fractions, I can multiply straight across and then reduce the fraction if I want to. I'd get 72 over 3, which is fine. Or I could maybe be even a little bit trickier. What could I do here?
Cross cancel.
I can cross cancel. When I'm multiplying fractions, I can cross cancel. So that would become a 3 and a 1, right? And then we end up with y minus 18 equals 8/3 x minus 24 over 1. Just 24. Okay. Last step, add 18. And then we end up with y equals 8/3 x, and then those are like terms. Negative 24 plus 18 is, I heard it, 6, and that's it. Right, there's our answer in slope-intercept form. Yes, sir. Yep. Okay, good. So now this is just one step harder. So what do we do here? This time they're not giving us a point and a slope directly, they're giving us 2 points. So what do we have to do? What do you think?
Y2 minus Y1 divided by X2.
Very good. So we got to use the slope formula first of all, right? We know slope equals y2 minus y1 over x2 minus x1. So help me out though. What numbers we plug? What minus what over what minus what?
12 plus 8, which would
What goes on the top though?
11 minus
Ah, okay, good. So we got the y's, subtract the y's first. So 11 minus 6 over, keep going, Kyle, what do you got?
12 minus.
12 minus -8, which becomes 12 plus 8. Okay, so that gives us on top, we get 11 minus 6 is 5. 12 plus 8 is, okay, so what's our slope reduced to then? Yeah, 1/4. Right, that would reduce to 1/4. So there's our slope. So we had to calculate the slope. Now we've got a slope. We've got 2 points, more than we need at this point. We only need one of them. So we'll pick the one that looks like it's the easiest to use. Slightly smaller numbers in that one maybe. So how about if we use that one? Either one would work though. Make it the same answer either way. And now I'm right back to there, aren't I? I've got a point, I've got a slope. We plug into point slope. So real quick, what is point slope again? Y minus equals times. Good. Okay, so if we plug stuff in then, I'm getting y minus 6, right? There's my y value of the point that we're using. Equals, what's my slope? 1/4 times x minus -8, so that becomes an x plus 8. Would agree? And now it's easy. Same darn steps every time. Now we're just going to distribute the slope and add like terms, and that we've simplified it into slope-intercept form, right? So last couple steps would be if we distribute the 1/4, we get y minus 6 equals 1/4 times x, right? Well, there's our mx, isn't it? 1/4 times 8, what's that? 2. And then last step, add 6. And so we get y equals 1/4 x plus 8. Okay? No problem. Okay, last two are just these word problems. Let's just rip through a couple of these real quick, and then you can have the rest of the period study for the test, get stuff taken care of. So here we got this friends and family, or friends of your family are purchasing a new home. The closing costs are $216 plus 2.75% of the purchase price of the home. So I'm telling you what the variables are in this case. If C represents the total closing costs and P represents the purchase price, write an equation to represent the total closing costs. So the first thing we got to ask ourselves, is this going to fit slope-intercept form or not? I'm hearing some no's and I'm hearing some yeses. Slope-intercept form would be the one if there's a rate and a start value. Okay, so can you see either one of those here so far? Is there a rate or a fixed cost / start value? Ah, there is, isn't there? 216 is the start value, isn't it? So we see right away that this has got to be y equals mx plus b style. It's got to be slope-intercept form. So then what we want to do here is we just want to start with a regular old, here's what I would recommend. And as you get better and better at this stuff, you might decide you can find some shortcuts to this. But let's do it this way for now. So we just want to start with y equals mx plus b, and we're going to write that for our application here. So instead of a y, first of all, what do we have? What's our output variable?
C.
C, yeah, because that's representing, we're trying to calculate closing costs, right? And so whatever we're trying to calculate is the output of the function, right? So C represents total closing costs, and it's telling us here the closing costs are all this stuff, right? So the Y is gonna become a C, okay? Well, if the output variable is the C, what must the input variable X be? It gotta be P, right? So that's our other variable. So here it is, we've got, P represents the purchase price, so instead of an X, we've got a P. Okay, you saw the B, right? The start value or the fixed cost, what was that? 216. Okay, so here we got the 216 plus, that's telling us that. And then the very last part, yes, sir, yeah. Very last part then is, what's the number, what's M? M is the number that's being multiplied by the input. Okay, there it is right there, right? 2.75% of something means the decimal of the percent times, right? Like if I say what's 25% of 100 or 25% of 200, what do? I multiply 200 by 0.25, right? So if I want to write this, then I want to figure out what B is. It has to do with this part right here, doesn't it? Okay, but if I want to turn this percentage into a decimal, what does that equal as a decimal? What do I have to do to make that a decimal? Got to go to the left by 2 places, so I've got my 2.75, and I've got to scoot over 2 places. So I need to add a 0 there, don't I? And then we'd always just, it's always a good idea to add a 0 in front, just so we don't miss the decimal. But it's kind of optional, right? And so there's our percentage written as a decimal, and so that's going to be 0.0275 goes in front of the P. That's it, right? That's going to be that's kind of messy. Let me clean that up. There. Okay, so there's our model, right? And then this, so that's what would go, all this stuff is just what would go there, right? Okay, what about part 2? Yes or no, if the purchase price of the home is $320,000 and your friends have $9,000, will they have enough to pay for the closing costs? How would we know?
You multiply 320,000 by 0.0275 and add 216.
There you go, right? So this is a value of the input, isn't it? So that's what we're gonna plug in for P, and just see what we get when we do that, right? So we would get C equals 0.0275 times 320,000 plus 216, and you'll have access to the Desmos Scientific on this part of the test, and so here's what you're going to get if you do that. Oops. You're going to get that, right? So there's what we get. If you plug in where we used to have a P, you're just plugging in that number in parentheses, right? So, oops. There we go. Take a picture for our notes.
So those be on the
Yes. Yeah, they will. Okay, and so then we can see that here, because look what the output is. When I input a 320,000, the output is 9,016. So did we have enough?
No.
No, we didn't. Right? We only had 9,000. So the answer would have been no. Right. Okay, last one. the change one here, so if Kyle's change jar contains only quarters and dimes, if C represents the total monetary value of change in his jar,
That should be-
collect change, where you go?
I'll hold your
I've
door.
seen
Yeah.
it, Kyle, I've seen it.
So, we wanna write an equation to represent the total value, so write an equation to represent the total value of the change in Kyle's change jar.
It's not even funny for you.
So,
That's your name.
so then, what's gonna be our output variable here? I mean, what's it gonna be? If we're writing the equation to represent the total value of the change, and C represents the total value of the change, yeah, it's gonna be a C equals, isn't it? Right, so right away, we know we get C equals something. Well, what about this other stuff? Q represents, he's only got quarters and dimes. Kyle doesn't mess around with pennies or nickels or any of that stuff, he only quarters and dimes. So, if Q represents number of quarters, what's the value of the quarters? 0.25 Q, right? We got that. Plus, what's gonna be the value of the dimes? If D represents number of dimes, what's it gonna be? 0.10 D, there's the equation, right? So if the total value of change is 1470, and Kyle has 42 quarters, the jar must contain a total of blank dimes. We're solving for what? What variable are we trying to find? D, right, we're trying to find D. We're plugging in values. What is this a value of here? C, good. So that's going in there. 42 quarters. Well, that's a value of Q, right? If I plug those things in, then the only thing left to solve for is D, which we can do algebraically. So what do we get? We get 1470 equals 0.25 times 42 plus 0.10 D. And that's what we're trying to solve for, right? So what would I do? Distribute, okay, or multiply, and so that's gonna give me 0.25 times 42 is just gonna be 1050. So now what?
Subtract.
Subtract, and then
Divide.
divide, okay? Good, so we'll subtract 1050 on both sides, and that's gonna give us, if we do that, we're gonna get good 420 equals, that stuff went away, so I just get 0.10 times D. Divide both sides by 0.1. 42, there you go. And what's our trick? You guys remember the trick from way back in the day. If I'm dividing decimals like this, I can take out the 0 first of all, and then what else can I do with that decimal? If I'm dividing something, if the top number has a tenths, and the bottom number has a tenths place, I could just scoot the decimal over in both, couldn't I? Same thing as multiplying both the top and bottom by 10. Right? So that makes it a little bit easier too. So we end up with then D equals 42 divided by 1, which is just 42. Whoops, how come I put 42? I think did I do that right? Oh, I did. How about that? That's pretty weird that the number of, it was the same for both. That's pretty bizarre.
Just kind of the way a cookie crumbles, man.
I guess so. How about that? Okay. So D equals 42, I guess, right? That works. Yeah, it does.
Now you know.
Huh. Okay, number of dimes is 42 also. That's really, what are the odds of that? Pretty bizarre. Okay? All right. I'm done. You can work. Why don't you flip your desk around real quick, and I'll just make the rounds. Wherever I see people struggling, I'll